In our last video, we built a roughly $2,000 streaming PC that didn't work all that well. Now, I really like the way this build turned out. I know some of you weren't a fan of the white fans, and that's totally fine. I can't possibly please everyone in a single video. Thank you for your candor, but I'm a fan of it, and that's what's most important. As long as you love what you build, that's all that matters. But what I don't love is when builds of mine don't work. So in this video, we're going to try to fix this one. Keyword there being try. I hope you'll stay with me. Say goodbye to thermal paste with Thermal Grizzly's phase sheets. These pads rely on a phase change material that allows them to liquefy during operation and effectively dissipate heat like paste without all the mess. In a nutshell, these are designed to last longer than normal paste thanks to thermal expansion behaviors around CPU and graphics card coolers and the resulting low viscosity of these sheets once they're up to temperature. This keeps more of the material from being, quote, pumped out after each thermal cycle, which is why they tend to last longer than traditional paste. But don't worry, they're easy to install and won't break the bank, so consider giving them a try for your next PC build. Learn more about Thermal Grizzly phase sheets by clicking the link below. Right, so there are a few things to address very quickly. This is going to be one big spiel of words, probably unedited, so if you want to skip ahead, feel free. I just think it's important to set up a few baselines here and clarify a few things that you probably saw from the previous video. Firstly, thank you for clicking on this one. As much as I hate doing a two-parter, I really had no choice. Some were asking why we couldn't just combine the two videos into one so that you didn't have to click on two. Greg, you greedy bastard. Well, let me tell you, we have many deadlines and many projects in the pipeline that would inevitably be delayed even further if I had waited to publish that video along with this video and then all of the stuff that we have to publish for the rest of October. It's like any other job, right? You have certain goals, certain expectations with other brands, and not just sponsored stuff. I mean, even like just random parts that are sent for review, etc. Those brands expect videos to be up at certain points in time, and so it would have just all cascaded. That's why I really had no choice here. Second, I want you to know that I read through many comments in the previous video, many more than I usually do. I tend to avoid the comment section after about the first hour of a video's publishing, but I really wanted to kind of get a gist of what you guys thought the problem was based on the symptom you saw. So let's recap that very quickly. You'll see that we assembled the system. Yeah, it looks cool. You know, some of you again didn't like the white fans, whatever, but the rig I thought looked really nice. I was super excited to turn it on and show you a few just quick benchmarks, how it would maybe stream perhaps or something along those lines. But it did not turn on at all. I pushed the power button. I tried jumping the power pins. We got nothing. And yes, my power strip was on. In fact, one way you could tell that it was that the system would fire up after clicking the BIOS flashback button. Interesting that the power button doesn't work, but the BIOS flashback button does, at least temporarily. It's one way to show that the system is receiving some power and is willing to at least somewhat fire up. It caught me so off guard in the moment. You see, this is a very candid reaction, and that's again why we had to end the video so abruptly, because I just was not prepared time-wise to troubleshoot a system that was exhibiting symptoms like this. I still to this day have no idea why it only turns on, albeit briefly, when I push the BIOS flashback button. We checked major connections. In fact, we'll go over all of that again here very shortly. But back to the comment section for a moment. This part of the video, in my opinion, is very crucial. It's important that we talk about this because so many of you pointed out this scene here. We were installing the CPU, and you noticed in the socket that there was either some sort of like foreign substance, or maybe there was a shadow or some lighting issue that made the socket not look normal. And so you attributed that to the symptoms you eventually saw. Well, my friends, two things. Firstly, your attention to detail is unmatched. I still to this day do not understand how you guys are able to pick up some of the things you do from the videos you watch. I've edited and filmed entire videos, even watched them in playback several times, and still not seen certain things that you guys do. It's pretty awesome, to be honest. I've learned a lot from your feedbacks. Thank you very much for that. Just wanted to give you a shout. Secondly, the motherboard that we're using here and that we used in this clip was actually used in a previous video as well, where we intentionally sabotaged the socket with thermal compound. If you have to know, it was specifically Thermal Grizzly Cryonaut, which is not electrically conductive, though it is very thermally conductive, which is why it works as a great thermal paste. So we filled the socket with said paste, and we smushed the CPU on top of it. I know, cringe. We didn't try to power it on. That's just something I wanted to point out. We didn't expect it would work, although there are accounts of that still working, including the original Reddit post that inspired this entire video. But I wanted to prove in that video that even if the socket is totally just sandwiched with paste, that it is recoverable. And so we used isopropyl alcohol, very, just frankly, terrible brushes to clean the paste as much as we could. There was some residue, some residual still at the bottom of the socket, but we didn't think it was worth trying to clean that because we didn't want to risk damaging the pins. All that said, at the end of the day, the board did still work. It still posted without issue. In fact, when I was assembling this rig that we have here, I noticed that the socket still had that residue. I didn't point it out because I didn't want to, raise any alarms, and I didn't think it would frankly be an issue either because we proved that it wasn't an issue in said video. A few of you mentioned that maybe the pins oxidized or something from the paste. No, the pins were totally fine. They were still very shiny, and I can assure you the CPU was installed correctly. I can't account for other things like maybe mounting pressure from the AIO. We'll tackle all of that, I imagine, in a bit. But I just wanted to throw that out there, that the board was confirmed working by the end of that video, and so I don't expect that that residual paste that is, again, not electrically conductive is actually causing the problem here. Alrighty, now here's what I think is wrong with this rig. So we confirmed that the motherboard worked after cleaning its socket. In fact, we confirmed that all of these components worked inadvertently in previous builds because none of them were brand new. It's why I didn't assemble everything outside of the case prior, just something else to clarify. But what I did do between that old paste video and this build video was update the BIOS. Or at least that's what I thought I did. See, Gigabyte's BIOS Flashback Plus feature is a bit finicky at times. You have to name each BIOS file very specifically. It has to be at the root of your storage drive in question. The storage drive has to be formatted a certain way, and it has to be connected to a specific port at the back of said motherboard. It's just very touchy, very particular. And I've done things exactly the way that they are spelled out in the manuals online, only to have those updates fail. And so maybe that's what's happened here. We actually have a dedicated video on the subject already on the channel if you want to check it out via the description. But long story short, it is a huge lifesaver for folks who maybe have much newer CPUs and much older motherboards that would normally support the new CPU with a BIOS update. But how can you update that BIOS if the chip you have isn't natively compatible with the board? Therein lies the problem, and this affected a lot of folks on the AM4 side of things with AMD for a good while. But later motherboards, especially like B550, X570 boards, started including this BIOS Flashback Plus or equivalent feature. So you didn't actually have to have any CPU at all installed in the socket in order for this update to occur. It doesn't involve the system fully turning on or anything, which is very nice, and that's the exact same procedure that I used here. Granted, I did have a 12th gen on hand that I could have used, but I figured BIOS Flashback Plus would have been faster. Maybe that was my mistake. So you can see here, power on our strip is good. We also have power on at the back of our unit, but we don't get any power, any sign of life from the rig. I've also tried jumping the power pins down here to no avail. I've also off camera checked every single connection in the system, including obviously the big stuff, the supplemental 8-pin PCI power here, 24-pin, etc., fan cables, HD audio, USB Type-C. It's all good. And our Passmark inline tester confirms there's nothing inherently wrong with our power supply. Again, not surprised by these findings. We suspect it's a BIOS issue anyway. I'm just trying to cover all my bases, treat this like I would any other diagnostic. The fact that this isn't powering on at all would normally suggest maybe there's some sort of power supply issue. We still can't jump the power pins here. We still can't get any power from the reset button here. The only way to get power is via this flashback button, which is it's just kind of crazy that that's what it takes. But then it cuts right back off again. So we do have a dedicated BIOS USB port here. Now this can be used for peripherals as well, but this is the port that you want to connect your thumb drive to with your BIOS loaded onto it so that we can update without a compatible CPU install. So you can see our motherboard here again. This is a Gigabyte Z690 Aorus Elite AX. We're on the product page now. I'm just going to show you where we can find BIOS updates. We'll click support. And then under downloads, we should see BIOS right here. We have 14 different BIOS revisions for this board on this product webpage. That's a lot, and a lot of these are just small incremental updates like microcode updates and the like, better DDR5, DDR4 support, etc. I think one of these actually includes 13th gen Intel support as well. So there are a few noteworthy ones that do, of course, add that extra support for later generation CPUs, just something to note. I believe the one that I tried to flash, and this might have been where I messed up, was It had to have been F30E because this was published on August 7th, and I did this. I think I did this early-ish September of this year. Now, again, where I think I may have messed up, this isn't the case for all motherboards, but sometimes newer BIOS updates require older BIOS updates be installed first, since they kind of stack on top of each other. I'm not sure if that's the case here. What I'm gonna try to do is revert back. I think F20 is a safe one. This adds support for 13th gen. We could, of course, move up from there to F21 or F22, but the original BIOS on this motherboard is F3. You can see they've made several improvements since then. Now we can take the downloaded BIOS file, we can drag it to the root of our thumb drive, and this is the important part. A lot of folks miss this. We need to rename the entire thing, including the extension at the end, to gigabyte.bin. Click enter, it'll ask if you want to change the extension, click yes, and there we go. Now we can safely eject and move on to the machine. We'll connect our drive to the port marked BIOS like so, and we'll make sure our power supply is set to the on position. Now here's where it gets tricky because I've done all of this before. In fact, this is I think how we ended up with a bricked system. I'm hoping this time around, especially since we're using an older BIOS revision, that this will work, but all we need to do is press the BIOS flashback button on the bottom of the board. That will power the rig up, pretty much like it is here. And you'll notice now it's actually staying on, it's not turning off. And I think that's because it detects a BIOS in the root of that USB drive. You'll also notice the flashing amber LED next to the BIOS flashback button. That's generally a good sign. From here, we're not gonna touch anything. And this is where things probably went wrong the first time around. See, I let things update and then I think the rig turned off and I just assumed, kind of like what it's doing now, it just turned off and now it turned back on again. So I assumed after it turned off and stayed off that the flash was successful. I didn't actually check at that time if the BIOS had been successfully flashed. Perhaps I should have. In fact, I know I should have. At that moment, I just assumed it worked because I have done this several times before. But like I said, every one of these is kind of finicky. I'm glad that this exists, but it's also difficult to deal with at times. It's just power cycling now.
A few moments later.
You know, I think it might have worked now because it's staying on. The rig hasn't turned off yet, but the fan curve has like kicked in. Like the fans are very quiet now. I think it's posted. We need to pull out a monitor. You'll notice the amber LED is no longer illuminated. That's a good sign. And you'll notice the debug light showing up now is for VGA, which would make sense because we don't have anything connected to our graphics card currently. So yeah, spoke a bit too soon there. Now I can't definitively say if it was because I prematurely disconnected the USB drive the first time around when the BIOS was supposedly updating, or if it was because I was using too recent a BIOS and didn't use like a middleman BIOS. Sometimes, you know, they rely on those. You can't just jump straight ahead to the newest one. So I'm not sure which was the cause of this sort of soft brick. The good thing is the board wasn't totally hard bricked as a result. And it looks like, yeah, just a quick BIOS flash with F20 in this case has got us back up and running. Now it's important to point out that we haven't powered the system off prior to the supposed successful BIOS flash. The reason I state this, well, okay, I'm breaking stuff already. The reason I state this is because some maybe novice troubleshooters, I was certainly in this boat at one point as well, may assume that just connecting an HDMI cable to a known working monitor would immediately result in picture out. You'll see here, we don't have any signal on this display. And even if I switch this to, say, the HDMI port at the back of the motherboard to run off of integrated graphics, we still won't get a signal out. And that is the result of a computer going through its post process and not identifying any monitor source from any of its display connections. So what it's gonna do at this point is just say, hey, we don't see any place to send picture out, so we're just gonna pause here. And the next step would be to power cycle. Click the reset button, maybe fully power off, then you can power back on. But the important thing is you don't draw any conclusions from this alone, because here you would just assume that it's still not posting. Well, the rig's still broken. It's really not. It just doesn't know where to send signal out. So if we click the reset button here, there we go. And we await with the HDMI cable already connected to the system. There we go. See, that's simple. There wasn't anything wrong with the system to begin with, but that could lead you to some incorrect conclusion. So, alrighty, that looks good. Now, as promised, now that we've fixed the system, I'm going to install Windows and we're going to run a few streaming tests. I'm probably not gonna be able to like simulate actually streaming. I'd have to go live for that. Maybe we could, I don't know, we'll see in a moment. But at the very least, I can maybe simulate recording via OBS while at the same time gaming, just to show you the extra workload that a system like that is expected to handle when essentially doing two very work-intensive things at the same time. That's what the system was built for, after all, basically a lot of multitasking. As you can imagine, setting up Windows on a new machine does take a bit of time. I was sure to update graphics drivers along the way and install OBS. Now this is entirely preferential. You could use Streamlabs, you could use other streaming services, recording software, but I like OBS because it's very lightweight and it has not failed me in over 10 years. Under the Stream tab is where we'll find our x264 and NVENC encoding options, and this is where you're gonna have to make a decision. This is gonna be a tough choice between using the CPU to encode said video or using the graphics card. This is why we spec'd our stream machine the way that we did. We have a very powerful Core i9-12900K and a fairly powerful 4070 as well. I know the 4070 gets a bad rep for being a bad value, but it is objectively a powerful card compared to a lot of what's offered today in the graphics card market, and it does a heck of a job encoding and not utilizing a ton of resources to do so. 9 times out of 10, I'll utilize the NVENC encoder personally, especially if I have like a 4070 or a 4080 at my disposal. But if I don't have a very powerful graphics card, maybe I don't have an Nvidia graphics card, I'll have no choice. I'll use x264 instead. And in that case, you want to make sure you have at least 8 physical cores, preferably simultaneous multi-threading or some degree of multi-threading. If it's an Intel chip, it would be hyper-threading, right? But I would say minimum of 16 threads just to give you some gaming headroom on top of the resources that'll be taken away while encoding. And well, let's jump straight into it. Now, I know this can seem like a lot of data thrown at you all at once. Don't worry, we're gonna take this piece by piece. I want you to start with the far left example. This is our control, our no streaming setup where we are just gaming and that is it. OBS is not opened on the streaming machine. This is going to give us a baseline. You can see our average FPS is somewhere in the high 180s to close to 200, and this is to be expected for a more high-end machine gaming in only 1080p. Shifting to the middle of the bunch, our NVENC scenario, notice we're recording with a bitrate of 10 megabits per second, of course the same for x264, and while we are a bit heavy on graphics card utilization in our control, especially considering this is only 1080p gameplay and a 1080p recording, the NVENC run suffers very, very little in the way of frame rate. Modern NVENC works phenomenally well at little to no visual cost, which is what we're after in the end. You'll just have to, pay for it, unfortunately, as most Nvidia graphics cards are not cheap, including the one we have here. Our GPU temps are only slightly warmer than our control as well, and we're using a tad bit more VRAM, but otherwise you'll be hard-pressed to differentiate between the two. Now let's discuss a scenario off to the far right. Boy, oh boy, x264. Look, it's still great, it's still used by plenty, and when paired with a high core count CPU like ours, and especially in the case where you don't have a newer Nvidia graphics card to take advantage of NVENC, the performance hit is pretty nominal. It's not enough to make me want to just go out and buy the next big thing from Team Green. Though it is important to point out that the x264 run did average a worse frame rate than NVENC in our 4070. It also resulted in significantly higher thread usage when compared to our control, affecting both power draw and temperature, and I suppose as a result as well, sound from our machine if we're not using locked fan curves. In my opinion, these trade-offs are not worth it when modern NVENC is an option. Again though, if it's not, if you have a Radeon graphics card, if you swear by AMD, or maybe even an Intel graphics card, you'll just want to make sure that you have a higher core count CPU to take advantage of the x264 encoding format. Oh, and if you're wondering how both of these recordings look in their rawest forms, minus, again, YouTube compression, what you're watching here, have a look for yourself. They're extremely sharp, both of them. And this is something you couldn't always say about NVENC in particular. They were often criticized for looking less sharp than their x264 equivalents, but that's not much the case today. Oh, and to further prove this point, I tricked you. These descriptions are actually backwards. The one on the right is NVENC, and the one on the left is x264. See? Virtually indistinguishable, even when we zoom all the way in. Of course, this may change slightly as we bump the recording resolution and bitrate, but we built this to be a streaming machine, and a vast majority of streams are handled in either 720p or 1080p, and are usually uploaded to sites like Twitch. And after Twitch's horrid compression, neither will look particularly crispy. So hopefully now it makes a bit more sense why we spec this rig the way that we did. We can never please everyone with a PC build. You'll always have the folks in the comments section, oh, you built with Intel. I absolutely absolutely hate it no matter what. Or, oh, you chose AMD, are you poor? You know, I see weird stuff like that all the time. And it just comes, again, with the territory, being a YouTuber and just being exposed to so many different people with so many different preferences. Whether I agree with them or not, it is the nature of the beast, and well, I stand by this because as you've just seen, this rig can do both very, very well. And that's how you know you've built a well-rounded streaming machine. We have enough cores at our disposal to stream via X264, no problem, and we have a beefy enough graphics card from Nvidia to stream via NVENC without virtually any hit at all in gaming performance, especially in a game where the card itself is being taxed very heavily and where you'd normally expect the card to, again, falter as a result. It actually did very well. And this is just a 4070. I know this is a lot of money, and I know that a lot of folks hate this card because a 70 series graphics card costing between $500 and $600 is kind of stupid. The price always just, Nvidia's gonna make sure you pay for it and then some. So, you know, of course, spec things how you want. I'm gonna have this listed in the description, all these parts linked below if you wanna build something just like this. I also briefly mentioned in the previous video, some of you got confused. You thought that the other PC part picker lists I was showing were for the build we actually assembled in the video. Those were just alternatives. So we had a performance-oriented one, which knocked out things like the 4TB NVMe and reallocated that money towards a beefier graphics card. In that case, an RTX 4080, which perhaps some of you makes more sense in a $2,000 build. And then the other option was an AMD one featuring the 7800X 3D. Now, at time of filming, that CPU was like $511. Didn't make a lot of sense. That's why I went with the 1200K here. But if you want to spend close to that, I think just because of like demand, folks are staying away from Team Blue right now. Those chips are kind of difficult to find at around $350, which I know some folks have paid for that chip. And that's a great price. $511 isn't. I think I'd rather have a 16-core AMD chip over a 7800X 3D at that point. Even though that CPU is arguably the best for gaming, it's just, again, a personal preference. And if I'm doing a lot of streaming and content creating, I'm gonna want those extra threads anyway. So I think that about wraps this one up. I am glad that we were able to get it back up and running again, just a dirty BIOS flash, and thankfully it went smoothly the second time around. Not sure what I did the first time. I'm still kind of confused by that, but thankfully the board didn't hard brick itself, and we were able to showcase just what this thing is capable of. If you enjoyed this one, give it a thumbs up. Consider subscribing if you have not already. Leave a comment down below. Check out relevant links and stuff in the video description, and consider sticking around for the next one. My name is Greg. Thanks for learning with me.